Alright, today I'm going to be talking about the quadratic formula, chapter 4.8. It is one of the most important formulas in algebra, and everyone should really know it by heart. Alright, for starters, the quadratic formula works to solve every quadratic equation. You can take the variables of any quadratic equation, a, b, and c, and plug them into the quadratic formula to get your answer. So before you plug in any variables from a quadratic equation, you first need to identify them. So for starters, this is what any normal quadratic equation looks like, and this is just an example. So we know that a is the first variable. We can identify that it is 2. The second variable is b, which is -4, and the third variable is c, which is -2. So now that we know our variables, we can begin to plug into our quadratic formula. So for starters, we're going to plug in b, which is -4. Since it's negative b in the quadratic formula and b is -4, we know that b is positive to start. Plus or minus the square root of -4 squared. And since two negatives equal positive, we know that it is 16 as that. Next, we do 4 times a, which is 2, times c, which is -2, all over 2 times a, which is 2. Alright, so now that we have all of our variables plugged in, we can begin to simplify even further. So, because of PEMDAS, we're going to start under the radical, and we're going to start with the multiplication. So 4 times 2 is 8, but since it's a -4, it's -8. So, and -8 times -2 is a positive 16. So we know that under here, it'd be 16 plus 16. And now we can go under and do 2 times 2 equals 4. Alright, so now that we've done that, we can go even farther with simplification with the radicand. So we know that 32 doesn't have a square root, but we do know that 2 times 16 equals 32, and 16 does have a square root, so we're going to use that to our advantage and bring it out here. So the square root of 16, and then the square root of 2. And 2 doesn't have a square root, so we can leave it like that, but 16 does. So we know we can go 4, because 4 times 4 is 16 with 2, and that's how we keep it. But from there, we have to plug it back into our equation, so we're going to bring it over here with 4 plus or minus 4 square root of 2 all over 4 again. Alright, for the next step, we're going to simplify again, and we're going to take this equation and we're going to see how far we can get it down. So one thing I notice when I look at this is that all these numbers have something in common. They all are divisible by 4. So we're going to simplify them a little bit here. So they all go into 4, so we know that 4 divided by 4 is 1, plus or minus 1, 2, all over 1. Alright, so believe it or not, this is our answer. No more simplifying. And one more thing we can do, we can clean it up a little bit. This is technically correct, but we can make it a little bit better. So since we know this is over 1, we know we don't need to write it in fraction form. We can just write it as 1 plus 1 square root of 2. And we don't need to show this 1 because it's just automatically there when you have a square root. So we can just write 2. And we know that this plus or minus represents plus 1 plus the square root of 2 and 1 minus the square root of 2. So we know this equals 2 answers. Alright, so another thing I want to talk about when it comes to the quadratic equation and the quadratic formula is answers don't always have to look like this with the square root in this. They can look a little bit cleaner with a solid, just a constant number. So I'm just gonna, instead of creating a whole new problem, I'm just gonna use our original thing and create a new little number for you. So we're gonna use the same thing, but we're gonna switch what the radicand is, and we're gonna change it to like 16, which has a square root. So we're gonna go 4 plus or minus square root of 16 over 4. And now this is a little different than what we just did, because now we can straight away, we know that 16 is 4 squared because it's a square root. So we're going to take it over here. 4 plus or minus 4 over 4, since that can change into 4. And now we're going to have two answers that don't have the weird plus or minus, square root of 2, all that stuff, because now we can have a little bit of a constant answer. So we're going to bring it over here. So 4 plus 4 over 4, or 4 minus 4 over 4. And from here we can take it even further and bring it down here. So 4 plus 4 is 8 over 4, which we know equals 2 because 4 goes into 8 twice. And then over here, 4 minus 4 is 0 over 4. And when you get something like this, you know it just equals 0 because there's 4 things going to 0. That's just 0. So we know that equals 0. So for an equation like this, you would have two answers, same as the other thing with plus or minus, but instead you just have your two answers. Alright, to teach you guys some specific situations you're going to deal with, something that doesn't usually happen, but if it does, I'll explain to you what you would do. I'm going to use this equation again and just change the radicand to make it a little easier so you don't have to come up with a whole new quadratic equation. And I'm just going to show you what happens if the radicand equals 0. So we're just going to use our good old 4 plus or minus, and let's say the radicand equals 0. So whatever you got here turned out to equal 0, something minus itself. And you got that, so you're like really confused because 0 doesn't have that. You can't take two things of 0 and split them up. You can't do anything like that. So what do? Well, it's actually pretty simple. You just know that it's 0. The answer is 0. 0 times 0 is 0. So you know that it just equals 0. But if you get 0, that means you're only going to have one answer. You're not going to have your two answers like we've been getting throughout everything else. You're only going to have one. That's the one thing that's specific about having 0. So we know that 4 plus 0 equals 4, and then 4 minus 0 equals 4. We know that happens. So we know that's the only answer we're going to get for that. And that would mean 4 over 4 just equals 1. And that's what our answer would be for that. So sometimes when you're doing problems, they can ask you for an exact value or an approximate value. And so I'm going to tell you how to identify the two. In fact, we actually already found our exact values for the other equations that we did with this equation. Our exact value is just this here. That's our exact value. But when they ask for approximate value, you have to figure out what is the approximate value. What would this number squared be, which is some crazy decimal, but that's where we have calculators. So you would take your, let's say your TI-84 or any calculator you have, and you would just try to solve on your calculator, and you would plug in your equation. For us, we're just going to use the equation we've been using the entire time, and we're going to plug that in. Once you've plugged in your quadratic formula all the way, you can try to solve and get your approximate value. In our case, it's that big number, but we're going to round to the hundredth place, so it would be 5.41. And then you don't really want to type that whole thing out again, so all you have to do is click enter, and you can go all the way over here, because remember it's plus or minus in quadratic formula, so we have to change it to a minus. And what do you think that's gonna, and we get our other one. So we get our two answers, both approximate values, and we get them both on the calculator like this. So that's how you find approximate value. All right, one last thing I want to talk about is when there's a negative number in the radicand, and we're using the same equation we've been using, we just changed it up to a negative 32. And when that happens, we have to use a imaginary number. Because when you have this negative radicand, you can have no real solutions. That just doesn't happen, because two negatives equal positive, so there's no two numbers that can multiply together to get negative 32, because that just doesn't work. There's not two of the same number. Like negative 3 times negative 3 is a positive 9, so there's no number that can multiply by itself in negatives that can equal a negative number. So that's just how we know there's no real solutions. And when you do get a negative, which does happen, you have to incorporate the imaginary number, which is just I. And you take it and you put on the outside of the square root, and you just change it to 32, and in our case it's just 4 plus or minus I square root of 32 over 4. And you do that for any situation that you get.